Researchers have found power laws in animal collective motion that are reminiscent of second-order phase transitions in equilibrium. Swarms are unique examples of flock formation. They inform about a marker and lack a global order but have a strong correlation with velocity. Research has shown them to be scale-free and to measure the static critical exponents gamma and nu. The dynamic connected correlation function partially collapses with a dynamic critical exponent of z equals 1.2. No theory captures this partial collapse feature of the results. Recently, published a series of papers demonstrating the harmonically confined Vicsek model with the dimension d equals 3, where n particles update their velocity by adopting the average velocity of neighbors within an interaction sphere of the radius, r0, modified by a linear confining force except for an alignment noise of strength eta. This confined Vicsek model has a novel, scale-free chaos phase transition that captures and explains the experimental results. We found a new critical exponent, phi, related to the largest Lyapunov exponent. We explain the partial collapse of the dynamic correlation function by the chaotic attractor being multifractal. Thus, the attractor has several length and time scales and therefore more than one dynamical critical exponent is needed to collapse the whole function. In ArcSieve, we obtain a higher dynamic critical exponent using different noise values and another fitting. Does the scale-free chaos phase transition exist in two dimensions? This is relevant because elongated cylindrical swarms have been observed. In this paper, we find that scale-free chaos phase transition exists in 2D with slightly different static and dynamic critical exponents. Here, we show the bifurcation diagram of the center of mass versus confinement. The deterministic solutions for n equals 128 start with period 2 and 4 solutions for large beta values, go through large period and quasiperiodic solutions for intermediate values and end in chaotic solutions for small beta values. The phase diagram of beta, eta, has periodic, quasiperiodic, chaotic, and noisy chaos solutions, noise-induced chaos, noisy periodic solutions and noise. For small confinement values, we find the scale-free chaos phase transition. This transition separates a multi-cluster chaos phase and a dispersed single-cluster chaos phase. The transition is the most compact swarm with a condensed core and vapor around it. We can characterize the phase transition in two ways. The first way is the well-known technique of finite-size scaling, in which we increase the number of particles to extrapolate the behavior for infinitely many particles, the thermodynamic limit. We find a partial collapse of the dynamic correlation function and the values of its static and dynamic critical exponents. Moreover, we obtain the new power law of the largest Lyapunov exponent with critical exponent phi. The second and novel way to describe the scale-free chaos phase transition is by fixing a value of the particle number and decreasing the noise towards zero. We find power laws in the noise and the critical line ends at the origin of the phase diagram, beta, eta. We obtain partial collapse and similar critical exponents with larger dynamic and phi critical exponents. Conclusions. The 2D harmonically confined Vicsek model has periodic, quasiperiodic and chaotic solutions. These solutions are modified by noise, and the noise may even induce chaos. The new zero-noise limit method captures and characterizes the scale-free chaos transition. At the transition, the swarm has a condensed core and vapor around it. We calculated static and dynamical critical exponents, and showed the partial collapse of the dynamical correlation function. The static critical exponents of the experiments are between the 3D and 2D harmonically confined Vicsek model exponents. This is because the vertical confinement should be weaker than that of the other two spatial axes.
Do you want to show your research progress to more scholars? Contribute an entry that will be linked to your paper on the encyclopedia platform, providing an opportunity for over 35,000 scholars to access and explore your research. Have you ever tried to show your latest research in a vivid way? Encyclopedia SciPlayer provides video production services to scholars. The service is in the trial phase and is currently free of charge. We welcome scholars interested in collaboration. Leave your information and we will contact you. Do you want to publish a new paper? Encyclopedia has an international, peer-reviewed, and open-access journal. Do you require a discount when you publish research in journals? Anyone who contributes to Encyclopedia can obtain vouchers for MDPI Journal's article processing charges. Encyclopedia aims to create an open-access knowledge-sharing platform for all scholars. To find more information, search for encyclopedia.pub.